curious little champions, I welcome you all to score 99% in 99 days. Today we are going to solve previous year questions from a cute little chapter, that is our environment, as cute as you guys. Now, what all type of questions we are going to solve over here? 1 marker, okay, 2 marker, 3 marker, 5 marker and 4 marker type of questions. So I believe that you are in. So without much talking, I'll just get into the questions. Here I have the first questions for my queries. So in the given food chain, suppose the amount of energy at 4th trophic level is 5 kilojoules. In the 4th trophic level, it is what? 5 kilojoules. What will be the energy available at the producer level? I didn't understand the question, ma'am. So basically, over here it is written that there is grass, my dear children, and grass is being eaten up by not so cute little grasshoppers, okay, and the grasshopper is being eaten by a frog. Frog is eaten by a snake, and snake is also not left. It is also being eaten by what? Hawk, which is a bird. Now I'll say grass is acquiring trophic level 1, T1. This is at trophic level 2, this is at trophic level 3, this is at trophic level 4, and this guy is at trophic level 5. So these are levels in a food chain. These are levels in a food chain. So trophic level 1 is the basic thing that is going to act like a food for all the organisms, okay? The base that you see over here. And these guys who occupy the trophic level 1, they are known as producers, my dear children. They are known as producers because these are the only guys who can produce their own food. We cannot produce our own food. Plants can produce their food. Have you seen us going and standing under the sun and waiting for CO2 to come in and H2O to come in? CO2 and H2O comes together to give glucose and things like that. Nothing like that happens over here in our case. Whereas plants, they do this particular process, and this is known as photosynthesis. They prepare their own food with the help of inorganic substances like CO2 and H2O. So CO2 and H2 comes together and basically somehow brings out the organic compound, that is C6H12O6 glucose. So they are the only producers. Rest all of them are kind of dependent on them. They consume. So I would call all of the other organisms as what? Consumers, my dear children. Now this guy consumes plants directly, so I'll call it primary consumer. This guy eats other organism that eats plant. This is secondary consumer, this is tertiary consumer, this will be what? Quaternary consumer. Now in the question given, in the given food chain, suppose the amount of energy at the 4th trophic level, this trophic level is 5 kilojoules, okay? Then what will be the energy available at the producer level? That is, it is asking about T1. How will you be able to find that out? I'll tell you one very easy thing that you need to remember throughout the chapter. There is a law which is known as 10% law, according to which only 10% of the energy is being transferred from here to here. Suppose I say that here it is 2000 kilojoules of energy. So how much amount of energy will be passed on to grasshopper? How much amount of energy? 10% of 2000. So 10% of 2000 means 10 into 10 by 100. I cut 0, 0, 0. What do I get? 200. So 200 kilojoules of energy will be available to this guy. Now this guy will also give only 10% of it to the next guy. So here it is given that T4, that is snake, it has what? 5 kilojoules of energy. So how will you be able to find out what is the energy over here in grass? We have to find that. So suppose we have to find T3 first, then we will come to T2, then we will come to T1. Okay, what is T3 over here? Whatever T3 content is there into 10% divided by 100 is equals to what? 5. That is the thing. So what is the energy available at T3? I'll say 5 into 100 divided by 10, right? So what do I get? Basically T3 has 50 kilojoules. T3 has what? 50 kilojoules. I see into 10 if I do, I get the answer. So into 10 I'll do 500 kilojoules. Again into 10 I do 5000 kilojoules. This will be the answer. This is the way that I told you to find it out. Okay, this is for T3. Again, you would have to replace this 5 by 50 over here and find it for T4. Then again, the same thing goes on. Not T4, T2. Okay? And the same thing goes on. So basically, what will be the answer over here, my dear children? In T1, that is the producer level, you would be having 5000 kilojoules of energy. 10% of it, only 500 goes over here. 10% of it, 50 kilojoules goes over here. 10% of it, 5 kilojoules goes over here. Now if you go ahead, it will be 0.5. Then there is no energy to give. That is why I'll give you one more answer. In the trophic levels, okay, in a food chain, there are no many trophic levels. This could be the maximum that could go. There won't be other organism that could eat it, because what will this hog give to the other organism? There is no energy to give only, which is why the trophic levels, the number of trophic level is also very few, because there is no energy to give. Okay, so remember the 10% law, and this becomes your answer. I hope it is clear. Now, going ahead with the next thing, accumulation of non-biodegradable pesticides in the food chain in increasing amount at each trophic level is known as. So, suppose this is the trophic levels again, and I am saying something is getting accumulated, some pesticide, as in pesticide is a chemical that is used to kill the pest. Okay, so that amount of pesticide is keeping on increasing. For example, grass had 2 mg, but this guy has 4 mg, this guy has 6 mg, this guy has 8 mg, this guy has 10 mg. The amount of pesticide is keeping on increasing throughout the trophic level, because it is getting accumulated. These pesticides, once it gets inside our body, it gets accumulated, because our body would not have a process to break it down completely. So the accumulation keeps on going on. And why do you think it is increasing? Because it's not just one grass, there will be group of grasses. Each of them will be having 2 mg of what? This particular pesticide. Now grasshopper will eat this bunch of grass also. For example, this has 2 mg, this also has 2 mg, 2 mg, you get 4 mg. Again, there can be a grasshopper that has 4 mg, another grasshopper with 4 mg. So if suppose the frog is eating 2 grasshoppers together, if it is eating 2 grasshoppers, then it will be 8 mg. Now frog also, if there are 2 frogs, each of 8 mg, let's say pesticide in them, then what will happen? Here it will be 16 mg. But anyways, it is getting accumulated, it is not going fall off. It is not basically falling off. The level is keeping on increasing throughout the trophic levels, because organisms are going to eat a lot from the below trophic level, right? So, and also it is getting accumulated in their body, because it cannot be broken down. These are chemicals, it cannot be easily broken down. What do you call this process of basically increase of the pesticide along the trophic levels? What do you call this process as? You call this process as biomagnification. You call this process as biomagnification. It is getting magnified. This level is getting magnified, increased. Okay. Now, accumulation of non-biodegradable pesticides in the food chain in increasing amount, they have mentioned, which is why it is known as biomagnification. If the question was accumulation of non-biodegradable pesticides in the food chain at each trophic level is known as, they have not mentioned about increasing amount. They have not mentioned about increasing amount, they are just saying that accumulation is happening. So what do you call this process? In that case, you call this as bioaccumulation. What will you call it? Bioaccumulation. But they are saying over here that it is increasing also. If they are saying it is increasing, you are talking about biomagnification. So always remember, biomagnification happens because of what? Accumulation. When something is getting accumulated throughout the trophic level, that's when it is getting magnified, the amount of it is increasing. Okay? If it is not accumulated, obviously the amount won't be increasing. So biomagnification is caused because of accumulation, but whenever the question comes that there is an increasing amount at each trophic level, it is talking about biomagnification, not accumulation. Okay, next thing. So in the given picture or in the given figure, the various trophic levels are shown in a pyramid. At which trophic level is maximum energy available? So maximum energy available will be at which trophic level? Each trophic level, as I said, 10% of things are being going. Here also when we saw, we started off with 5,000 and it is going lesser, right? When we go above, it goes lesser. So which one will be having the highest amount of energy, children? Always T1. Always the producer will be having high amount of energy, because it is getting energy directly from the sunlight. Only 1% of energy is coming, but still it is coming. Okay, some amount of energy is coming. So it is the one that receives it directly, which is why I will say T1 is the one that has the highest amount of energy. Please do not go right ulta T1, T2, T3, T4. Don't do that. One starts from here. Okay, always remember, and one is always occupied by the producers. Okay, so it is generally plants in the case of terrestrial. In the case of aquatic life, what are the organisms that basically in aquatic life, what are the organisms that basically comes in T1 in pond ecosystem and all? T1 is occupied by phytoplanktons. Spelling of phytoplanktons goes like this. So always remember, if they have mentioned phytoplanktons, you are basically talking about the plant-like organisms which are there. Basically, you're talking about the plant life only in the aquatic life. In the aquatic ecosystem, you call them phytoplanktons. They're small things. They're not exactly plants, okay? But I'm telling you, in general, they are going to play that role of taking in energy from the sun. So they are going to play the role of producers in aquatic ecosystem. And feeding on them, you have zooplanktons occupying the next trophic level. Zooplanktons are eaten by small fishes. Now the small fishes are eaten by big fishes. This is the thing that goes. So this is T1, this is T2, this is T3 and this is T4. I am explaining you other concepts also because you should be able to solve other questions also. Works? Next. Study the given figure of a food web. What do you mean by food web? When there are interconnecting food chains. Now it's not like the grass can be eaten only by the grasshopper. There will be other organisms also there to eat the grass. A rabbit will be there, some other organisms could be there, cow will be there. So the food chains are kind of interlinked, okay, and you now call this as food web. So study the given figure of a food web and identify the primary consumer in the food web. Who are the primary consumers? I told you, which directly feed on the producers. My dear children, they were known as primary consumer. These are secondary consumer, these are tertiary consumer, these are quaternary consumers. So one that directly feeds is known as primary consumer. It will be always an herbivore. It will be always an herbivore or it can be omnivore also. Omnivore means that organism that can eat both plants as well as animals. But mostly it is an herbivore. Remember that. So over here we have to spot that herbivore. So plants, grass, seeds, everything is plant product only, which has been eaten by mice over here and rabbit over here. So can I say that these are the primary consumers? They are going to directly feed. Can I call fox a primary consumer? No, it cannot. So these are the ones that are known as the primary consumers, that is mice and rabbit, and D becomes your answer. Cool? Works? Chalo. Next question, assertion and reason. You have to be really careful here. So the energy which passes to the herbivores does not come back to the autotrophs. The energy which passes to the herbivores. What do you mean by that? For example, you had grass. Same example I am taking, okay? And you had grasshopper. So it is saying the energy which is given, okay, the 10% of things that are given, it does not come back to the producer. They have written autotrophs. What do you mean by autotrophs? Autotrophs are organisms that can prepare their own food. And I told you, there is only one autotroph, that is the producers. Okay, so the energy which passes to the herbivores does not come back to the autotrophs. Assertion is that it is true. It does not come back to the autotrophs. Always remember, the flow of energy is unidirectional. So that is the reason the flow of energy in a food chain is always unidirectional. It is only one direction that the thing goes. It does not come in the opposite direction. You cannot create energy over there. Okay. So this is the correct answer. The energy which passes to the herbivores does not come back. Herbivores as in these organisms that eat the producers, right? So it does not come back over here. That is true. Why? Because the flow of energy in a food chain is always unidirectional. So I'll say both A and B are correct, and B is the correct explanation of A as well. Okay. Next question. An ecosystem consists of biotic components and abiotic components. Biotic components as in living components. For example, you have us. We are a living organism. Decomposes. They are living organism. Abiotic components as in water, wind, everything, soil, everything is abiotic. That is not living. Not living things basically come under abiotic thing. So when I say an ecosystem is there, ecosystem is a group of biotic as well as abiotic components. I agree. So assertion is completely true. Now talking about reason, biotic and abiotic components play important role for the sustenance. Spelling of sustenance is wrong. Okay, sustenance of life and work independently in all ecosystem. Independently as in they are not dependent, they are independent. Do you think we are independent of the water that is there? No people, no. Because we basically drink water, we need food. Everything is basically non-living things only. So can we say it is independently? No. We are dependent, we are interdependent on each other. Abiotic and biotic components are basically interdependent on each other. So this is a wrong statement. Okay. So ecosystem consists of biotic components and abiotic components. That is correct. But the reason is false. So I'll say A is true, but R is what? False. Chalo. Next question, which is a 1 marker question again. Choose the option giving correct matching the items. Choose the option giving correct matching the items given in column 1 and 2. Oh, so basically we have to match column 1 and 2. Okay. So we have physical environment over here. Physical environment matches with what? Physical environment matches with ozone layer, bacteria and fungi, abiotic components, skin cancer. Let's leave physical environment. If you think you're confused, let's leave it now. Talk about exposure to UV radiation. So we all know we put sunscreen and all. Why, children? Because we are basically protecting our skin from UV radiation. Because if we are not using sunscreen and all, probably there are chances that the UV radiation could fall on us, create some changes in our DNA and stuff like that. Basically it can lead to what? Skin cancer. So exposure to UV radiation is always linked to skin cancer. Okay, and over here if you see A option, all the A option is matched with 3. All the A option is matched with 3, so hence we do not have to find the answer anyways. So physical environment, we are talking about abiotic components. Okay, in the physical environment there are abiotic components. But the B option is what? Matching with 4. B is matching with 4, so we can cancel this option and this option. We have these 2 options left. Now let's talk about chlorofluorocarbons, which are also known as CFCs. What are those? CFCs. So chlorofluorocarbons are kind of villains in the story. Okay, what do they do? There is a very pretty layer, okay, in our stratosphere. Okay, and this particular layer is going to protect us from the harmful UV radiation. Okay, and this layer is known as ozone layer. What is it known as? Ozone layer. The CFC guy is going to create problems in the ozone layer. It is going to make holes, little holes in the ozone layer, which is a big problem. So chlorofluorocarbons are the ones that is responsible for ozone layer depletion, which means C goes with 1. The C option will go with 1. So I'll say this is the option, but let me check the D option also. Decomposers, what are those? Decomposers are organisms which basically feed on bacteria and fungi. Is it true? Decomposers are organisms that feed on bacteria and fungi? Decomposers are organisms that feed on dead and decaying matter. Okay, and bacteria and fungi are known as what? Decomposers. Okay, bacteria and fungi, they are known as decomposers because they are going to be the ones who feed on dead and decaying matter. And there is a way to remember it. Okay, you know Facebook, FB, so fungi and bacteria, they both are decomposers. They both are decomposers. They are going to feed on dead and decaying matter and basically break it down into smaller components, inorganic substances which plants and everything can reuse. Okay, so that is their role, very important role they play. So I will say D is going with 2. So with this we say this is the correct answer, my dear little champions. Cool? Chalo. Next. Now we are going to start the 2 marker questions. Okay, write one difference between biodegradable and non-biodegradable waste. What do you mean by a biodegradable? Biodegradable as in these waste, whatever is there, can be broken down naturally with the help of our decomposers and everything which is there in the soil. Okay. Whereas when you talk about non-biodegradable, that means it is not an easy process. It cannot be broken down naturally. We have to probably use chemicals. We have to probably use heat for breaking them down. So that is one big difference between biodegradable and non-biodegradable waste. They are asking about one difference. I told about one difference. Now list 2 impacts of each type of accumulated waste on the environment if not disposed of properly. So they are asking you give 2 impacts both for each biodegradable and non-biodegradable, and this is a very important question. I'll tell you, every time this type of question comes from this particular topic, biodegradable, non-biodegradable, so we usually think that biodegradable waste, it can be broken down, so it should not be a problem, right? But it is also a problem because you might have seen, okay, people, okay, presently this video has been shot in Bangalore. In Bangalore also there are lots of areas where waste collection is not very proper. So what do? People, they dump their waste in certain areas, and what happens in that certain areas? There will be house flies, there will be so many organisms goofing around the area and causing trouble. How do they cause trouble? Basically, first thing, that area will be having lots of foul smell. Now this foul smell will be attracting a lot of houseflies. The houseflies will come sit on that, and then the houseflies will come sit on our food and basically pass the disease which is there. So it is going to act like a vector. It is going to act like a vector, the houseflies. Basically, we are helping in transferring diseases from organisms to organisms. We do not move on that. So that is 2 very big problems of what? Biodegradable waste. It can create what? Foul smell, and also basically it can make so many, it can basically help in the cause of so many vector-borne diseases which are being passed down with the help of houseflies. Okay, now we have to say two problems of non-biodegradable waste. Now non-biodegradable waste, it will be obviously taking lots and lots of time to get broken down only if we put chemicals or basically treat it with heat. So this accumulation can lead to less of space. There will be filling of landfills. You know, landfills are being made where a big thing is being drawn out from the soil, and this area is being used to fill the non-biodegradable waste. But for how long? How much do you think that this area can accumulate? After a point, obviously everything will start getting outside and there won't be any space left. You get it? So that is one big problem. Second thing, what happens is that when we are putting chemicals and things like that, when we are putting this plastics and things like that, okay, and when UV rays and everything falls on it, obviously certain chemicals are being released from them. Certain chemicals are being released from them which directly seep into the soil. And the soil, it goes to the water bodies also. From soil it goes to the water bodies, and who are drinking this water bodies, children? We people only are drinking this water bodies. So basically, aren't we creating a problem for ourselves? Yes. So these chemicals are going to cause a huge lot of trouble later on in our life. So how do you frame this answer? First thing, the difference is between biodegradable and non-biodegradable substances that can be decomposed naturally by the action of microorganisms. Non-biodegradable substances that cannot be decomposed naturally. It needs what? Some heat or probably a treatment with chemicals. Cool. Now over here, effects of biodegradable waste on environment. Decomposition of biodegradable waste is accompanied by foul smell which spreads in the environment and affects the people of nearby area. That is one problem. It acts as a breeding grounds for housefly which can act as vector for various diseases. I will give you an example. You have amoebiasis, amoebic dysentery being caused. What do you mean by dysentery? Dysentery is basically stool with blood and mucus. So people will get that particular disease also. You can never imagine that we can get that diseases. So it can spread. So please tell, if someone is there and you are seeing that someone throwing waste here and there, please tell them not do that. Okay, it's not a good thing. Now, effects of non-biodegradable substances, basically excessive use of non-biodegradable pesticides increases the soil pollution and also affect the soil fertility. But it's not just about pesticide, it's about any waste. When they are broken down, it is going to create a huge lot of trouble. Now, certain non-biodegradable waste enter the food chains and affect the various biotic components of the environment. Biotic components as in same thing that I said. Okay, basically soil, water, it is going to affect a lot of things. And as I said, it is going to use a lot of space. Uses a lot of space for storage, which we actually do not have. Okay, so that is one big thing. So this could come for a 3 marker also, this could come for a 4 marker also, we never know, so be prepared for these type of content. Now next thing, again a 2 mark question, write the percentage of solar energy captured by autotrophs. So there is a plant and I told you plants are the first organism that captures energy. So how much energy do you think that they absorb from the sunlight? It's only 1 to 2% of energy, my dear children, that they take from the sun. 1 to 2% of that energy is being taken, okay, by the autotrophs. It is being fixed by the autotrophs, remember that. Now, energy, what is the energy transferred from the autotrophs to the next level in the food chain? For example, a grasshopper. How much energy is being passed on? We studied about one law, right? What was that law? 10% law. 10% law starts from here, from the trophic level 1 to trophic level 2. So 10% amount of energy is being taken. Do not write 10% here. I'm going to kill you if you write that, okay? Always remember, from the sunlight, only 1 to actually 5%, but in your book it is not given 1 to 5%. So let's stick on to 1. That will be much safer option. So 1% of energy is being taken over here. Now from this 1% of energy that is being taken over here, okay, whatever is there, next to the next trophic level, only 10% is being transferred. Cool, 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 cool. Okay, chalo. Now, what are trophic levels? Trophic levels are what? Basically stages that is there in a food chain. Stages that is there in a food chain through which basically the food as well as the energy it passes. So why do different food chains in an ecosystem not have more than 4 to 5 trophic levels? I already explained you this. Why do you think they do not have more trophic levels? Over here in the first question itself I explained you, right? Why do you think there is no much trophic levels over here. If we keep one more organism above it, what will happen, my dear children? So 5000 kilojoules were here, 500 was here, 50 was here, 5 was here. 10% of 5 is 0.5. Now do you have some energy to give to the other organism that will come throughout? No, we do not have the energy, because according to 10% law, only 10% of energy is being transferred, which is why we have to restrict the level of trophic levels in a food chain. There is no energy to give. That's the reason. So we will come back to this question and we will see how we can write the answer. First thing, the autotrophs, how much energy did they capture? 1% of the solar energy that falls on the leaves for the process of photosynthesis. Now, the next thing, from the autotroph to the next trophic level, how much amount of energy is being transferred? According to the 10% rule, there is only 10% flow of energy from the trophic level to the next higher trophic level. So only 10% energy will be transferred from autotrophs to the herbivores. Okay, herbivores. Now, what do you mean by trophic level? The various steps in a food chain or ecological pyramid at which the transfer of food or energy takes place from one organism to the other organism. This is how you have to write. Now, what is the reason why we do not have so many trophic levels, my dear children? The reason is that there is only 10% flow of energy from one trophic level to the next higher level. The loss of energy at each step is so large that very little usable energy remains after 4 or 5 trophic levels. Hence, only 4 to 5 trophic levels are present in each food chain. So we have so less amount of energy left throughout the trophic levels when we go up. So that is why there is no more addition to it. Cool? Works? Chalo. Next question. We do not clean ponds or lakes. Okay, but an aquarium which is there, oh my god, okay, needs to be cleaned regularly. Why? Why do you think we need to clean the aquarium and not the ponds and the lakes? What is the thing? Because in an aquarium, we are not going to add decomposers there. We are not going to put detritivores there. But in the ponds and the lakes, they naturally have it. They naturally have the decomposed, they have the detritivores, which are going to break down the organic compounds into inorganic substances. Okay, which is going to break down all the excreta and things like that. Which is going to break down the organic things into inorganic things. And these inorganic things can be utilized. So, in the ponds it is naturally occurring, but in the case of an aquarium it is not there. It is a man-made thing. It is a man-made thing. It is not a natural ecosystem. This is what, children, artificial ecosystem that we make. And we are not going to put decomposers, that is fungi and bacteria and anything in that, which is why we need to clean it regularly. Otherwise, basically this job is done by the decomposer and detritivores. Okay, so how do you frame this answer? First, we'll read that. We do not clean ponds or lakes, but an aquarium needs to be cleaned. An aquarium is an artificial ecosystem and does not have enough population of decomposers to decompose waste materials produced by the aquatic animals. Ponds or lakes are natural ecosystems that have plenty of producers, consumers, and basically decomposers as well. Cool? So that becomes the answer. Now there is one more part to this question, that is, why is ozone layer getting depleted at the higher levels of the atmosphere? That means in the stratosphere and all. Why do you think the ozone is getting depleted? Mention one harmful effect caused by its depletion. So it is getting depleted because basically we are using a lot of devices which releases chlorofluorocarbons. What are those things? We are using refrigerators, AC, which is going to release a lot of CFCs. And these CFCs, what do they do to the ozone layer, my dear children? Do you know what is the formula for this? It is O3. It is what? O3. And what happens when basically chlorofluorocarbons come in? No. When chlorofluorocarbons come in, they go and attack the O3 and they try to break the O3 into what? Oxygen and O. Oxygen and O. Now this O attaches with the Cl and it forms chlorine monoxide. It forms chlorine monoxide, which is again going to cause trouble. Anyways, it is breaking the ozone. Anyways, it is going to break the ozone. So it is going to cause a breakup over here. It will divide O2 and O. Now this O will go and mingle with what? The Cl, the chlorine which is there, and form chlorine monoxide. Okay, what do you call? You call it something else, but yes, anything. So this is how it is getting depleted at higher levels of atmosphere. Now what happens if this depletion is being caused? What happens if O3 or basically ozone is not there? When ozone is not there, the UV rays which are there, So O3 is kind of, the ozone layer which is there, it is kind of a protection from the harmful UV radiation. It kind of stops it. Okay, if O3 is not there, this guy will come in and basically cause skin cancer and that cancer and this cancer in us. So that is one harmful effect caused by its depletion. Now, the ozone layer is getting depleted at higher trophic levels of the atmosphere due to the action of chlorofluorocarbons, that is CFCs. CFCs are used in refrigerators and fire extinguishers. Depletion of ozone layer is allowing greater amount of UV radiation to reach the earth. What happens with the UV radiation? UV radiation can affect the ecosystem by affecting photosynthesis in plants. In the plants also it is affecting. In human beings, it is causing skin cancer, cataract. Okay, what is it causing? Cataract in the eyes, and also damage to the immune system. These 3 points are kind of very important. Please remember it. Okay, what does UV radiation cause? Skin cancer, cataract eyes, as well as basically damage to the immune system. It's not cataract eyes, cataract in the eyes. Okay, and damage to the immune system, not ecosystem. If I said ecosystem, I am sorry. Okay, will you be able to write it? We will be seeing so many questions from ozone because ozone is a very repeated question. Okay, there are topic, so we will be seeing it. Do not worry. Okay, now it's a 3-marker question. Indicate the flow of energy in an ecosystem. Why is it unidirectional? Justify. Why do you think it is unidirectional? It goes in one direction only. Because basically in ecosystem there is a law being followed or rule being followed, that is 10% rule, according to which only 10% of energy is going from one trophic level to the next trophic level. Okay, you have to indicate the flow of energy. So you have to make a make a food chain by yourself. So over here made a food chain, sun is there, producer, sun is basically going to act on producer, producer is going to be eaten up by herbivores, herbivores are eaten up by carnivore. Now why it is unidirectional? Since the flow of energy is progressively from one trophic level to another and does not revert back. Okay, they are explaining you why it is unidirectional. So you have to first say, what do you mean by unidirectional? So it is going in one direction only, that is from the lower trophic level to the higher trophic level. This is what you mean by unidirectionality. Now further, the available energy decreases in the higher trophic level, making it impossible for energy to flow in reverse direction. Obviously when you are giving, you're giving only 10%. So what do you expect? Can you give it back? No, there is no use of it. There is no point of it. There is no point of reversibility over here. Okay, it is kind of impossible. You're giving so less energy back. Again, when you're giving, you might be losing some energy. Energy, right? You might be losing some energy. The organism that is there, it is going to utilize some energy, right, for itself. There might be some energy lost in the process of giving. So obviously there is nothing to give back. So that is the thing, which is why it is always unidirectional. Got it? Now, explain the role of UV radiation in producing ozone layer. Now, how is UV radiation going to help in ozone layer, in the ozone layer formation? Do you know that? How UV radiation help in the formation of ozone? So, suppose this is oxygen. This is your mighty sun. The sun put UV radiation, and this UV radiation is going to break this oxygen into what? O and O. This O which is there can go and interact with another oxygen. This O which is there, it can also go and interact with another oxygen. What do you get? O plus O2 gives you O3. Here also you get O3. So basically this is how UV radiation is going to help in the formation of ozone. And this ozone is going to protect you from what? UV radiation as well. Just give me a second, children. Okay? Just give me a second. I'm getting a call. Where are you? Where are you? Yes. So sorry for that. Yeah. So basically this is how we get the O3. And how will you answer it? In the form of answers, let's see that. So ozone is formed in the upper atmosphere, that is stratosphere, when the solar UV radiation dissociates molecules of oxygen, dissociates as in breaks down molecules of oxygen O2, and then this oxygen atom, that is O. First of all, over here it's O2, and then this oxygen atom O combines with an oxygen molecule, that is O2, okay, giving rise to what? O3. Now the reaction, mention the reaction involved, you have to make the reaction. O2 gives out O and O. This O and O basically can go and react with other oxygen, giving out O3. So this is how we can write. So O2 breaks to O and O under UV radiation. So on the line, that is this line, you have to mention that. UV radiation. And the next thing that you have to do is make this O combine with another oxygen to form O3. This is the reaction involved. Why is excessive use of CFC a cause of concern? Because CFC are going to break this O3 down back into what? Back into O plus O2. The opposite of this thing is going to happen if CFCs are there. And then later what is happening? The chlorine which is there is going to combine with this particular oxygen. Okay, so when CFC reach the upper layers of atmosphere, they cause depletion of ozone layer and allow harmful UV radiation to reach the surface of the earth to create health hazards. Cool. So everything is linked. Remember that. Now this is a thing that is happening over here. What does CFC do? Let's see. So CFC is basically, there is a C, okay, there are two Cl, that is chlorine, and one F fluorine, chlorofluorocarbon. Okay. So over here, this Cl which is there, it is going to dissociate O3. It is going to break down O3 into what, children? Oxygen and one oxygen atom. Now this oxygen atom is going to combine with Cl to form chlorine monoxide that you see over here. So basically you are breaking down the ozone which was being made with the help of UV radiation. Works? Okay? Chalo. Now, time for a 5-marker question. Give two differences between food chain and food web. What is the difference between food chain and food web? Food chain is basically talking about different trophic levels which are there. Food web is basically interconnecting food chains. Food web is basically what? Interconnecting food chains. Now over here, we can see the difference. A series of organisms feeding on one on the other is what? A food chain. It consists of number of interlinked food chain, that is what? Food web. Over here, members of higher trophic level depend for feed on single type of members of lower levels, right? So for example, frog were depending on grasshoppers only in one type of food chain. But when you talk about food web, do you think frog depends on one type of only grasshoppers? No, it will be depending on other insects also. So members of higher trophic levels can depend or feed on members of different food chain. So it is not just it is restricted to one food chain, basically different organisms are there. So these are the two examples that you basically differences that you can write both for food chain and food web, my darling children. Now, what are decomposers? What are decomposers, dear children? Decomposers are organisms that feeds on dead and decaying matter. That feeds on dead and decaying matter. Example is fungi and bacteria. Okay. If all the decomposers vanish from ecosystem, will there be an effect? Do you think there will be an effect? There will be an effect. What will happen? The dead and decaying thing will be there only. It will get accumulated. So the organic compound which is there in the dead and decaying matter will just there. It can cause you diseases also. Nothing is getting decomposed, right? It can cause diseases. Next thing, the usual job of this particular organism was to break down organic things into inorganic things. And these inorganic stuff was being used by what? Producers. That is basically the plants to make what? Food onto which all the other consumers are dependent. So don't you think if these guys are not performing this function, this won't be able to perform this function, and if this is not being functioned, do you think we can survive? No, basically you are going to cause a huge lot of trouble to the whole ecosystem. So decomposers are kind of really important. How can you frame your answers? First thing you say, these are organisms which feed on dead and decaying matter. Example is what? Fungi and bacteria. Now if all decomposers vanish from the ecosystem, do you think there will be an effect? There will be an effect. Okay, there will be an effect. What is that effect? Basically, the things will be getting accumulated. That is one problem. That will lead to diseases. Second thing, the organic compounds won't be broken down to inorganic things, and these inorganic things would not be used by producers to make their food, and hence the consumers won't be able to live also. So anyways, the ecosystem that you see will be totally getting damaged. So organisms that decompose the dead remains of plants and animals are called as decomposers. Example you have to write, please write fungi and bacteria, FB. As decomposers are involved in decomposition process, their absence would what? Halt the decomposition process. Second thing, accumulation of dead and decaying substances in nature. It will be accumulated. Third thing, all natural resources will start getting extinct. Yes, it will, because everything is basically dependent on what? Inorganic substances. Cool. Chalo. Now the last question, which is a 4-marker question, is a case study based question, my dear children. And again, you have ozone being over here, and I'm going to tell you one more extra thing about ozone. Listen to me very carefully. Okay, read the given extract and answer the question that follows. The atmosphere is a blanket of air and a precious natural resource for sustaining life on earth. Unfortunately, human activities based on national and personal interest are causing harm to this common resource, notably by depleting the fragile ozone layer, which act as a protective shield for life on earth. Ozone molecules consist of 3 oxygen atoms. Ozone molecules are exceeding rare, fewer than 10 in every million molecules of air. However, for nearly a billion years, their presence in the atmosphere has played a vital role in safeguarding life on earth. The ozone in the troposphere is bad ozone, which can damage lung tissues and plants. Troposphere as in the layer that we are living in, okay, basically, okay. Now, but about 90% of the ozone found in the stratosphere between 10 to 40 kilometers. This is what, up to 110 kilometers above the earth's surface, okay, which is there in the troposphere. That is the first layer. Then after that you have the stratosphere. Okay, so we are living here, we have troposphere, then the stratosphere. So in the troposphere, this ozone is not really good because it will come down in our layer also. It will be coming down in our layer. And ozone is not good in our layer if it is coming in the ground level. Okay, this is a question that has come. Why ozone is not good in the ground level? Because ozone basically is going to cause a lot of respiratory issues, my dear children. It is going to cause a lot of respiratory issues. It is going to combine with nitrogen that is there in the atmosphere, can make these type of things, not these type of things, basically some other very toxic compounds which can cause other diseases also. So it causes respiratory issues in us, in the plants also. It halts the process of photosynthesis. There are a lot of trouble being caused by the ozone which is in the ground level, not by the ozone that is present in the stratosphere. In the stratosphere, it is really good for us because it protects us from UV radiation. Always remember. So there is bad ozone, there is good ozone as well. So good ozone is there, which plays a beneficial role by absorbing dangerous ultraviolet radiation from the sun. Without this beneficial ozone layer, humans would have been more susceptible to certain diseases due to increased incidence of ultraviolet rays from the sun. Where ozone holes are more pronounced? Where do you think that ozone holes are more pronounced? You will find more ozone holes there, in holes in the ozone. It is usually found in the polar region such as Antarctica. So Antarctica was the first port where the ozone hole was being found, but now it is said that it is being recovered, okay, it is being reforming again. So this was the area where it first saw, because why I went and read ahead about it. I found that there are clouds being formed, and these clouds have high amount of chlorine and fluorine over there in the polar region because of the temperature things. They hold a lot of chlorine and things like that. And these chlorine and fluorine, you know what do they do to the ozone layer, which is why they have a hole up there, okay, in Antarctica region. So this is the area where it is more pronounced. Now ozone molecules consist of which type of atoms? Ozone is made up of what, children? Oxygen atoms. Oh, it is made up of oxygen atoms, which is found when O combines with a molecule of O2. Okay, you can write that also. Which disease is caused by UV rays in humans? I told you there are 3 things that you have to write. Okay, what are the 3 things? First thing, skin cancer. Second thing, cataract in the eyes. Third thing, what's a deficiency, immune deficiency that is happening. So 3 things you have to write. Always remember 3 things you have to write. First thing, skin cancer. Second thing, cataract. And basically third thing, loss of or basically presence of immune deficiency. Your immune system is kind of deficient. Okay, now the next thing, which substance is an ozone depleting substance? Which substance do you think is an ozone depleting substance, my dear children? It is none other than CFCs, that is chlorofluorocarbons. How do you write the answer? You can write the answer like this. Ozone holes are more pronounced over the polar regions, particularly Antarctica. Ozone molecules consist of oxygen atoms. Each ozone molecule is made up of 3 oxygen atoms, O3. You can also write how it is made. It is made by O and O2, gives rise to O3. Now, excessive exposure to UV rays can lead to certain problems like skin cancer, cataract, suppression of the immune system. Now, chlorofluorocarbons are the one that are major depleting substances of ozone. And with this, we are completing all the questions of this particular chapter, and I hope that this was helpful for all of you guys. And And if you think that this particular video was helpful, do not forget to subscribe to our cute little channel. And also, my dear children, please don't worry about any exam. It is going to be really good. Just give your 100%. I trust in you. All the other teachers trust in you. We have the whole belief that you guys will be doing really, really great. Do not forget to follow whatever we are teaching. We are giving a lot of stuff. We are spending a lot of time for you guys, for teaching you things. So basically make use of all this thing. Yeah, so that's all. Wishing you a good day ahead. Bye bye. Take care, sweeties.